ʻOumuamua was the first confirmed interstellar object ever detected passing through our solar system. It was discovered in 2017 and measured roughly 400 meters long with an unusual elongated shape. Unlike typical comets, it showed no visible tail of gas or dust. However, astronomers observed a slight but measurable acceleration as it moved away from the sun. This puzzled scientists because there was no obvious source of propulsion. Later studies suggested that hydrogen gas trapped inside the object could have slowly escaped when heated by sunlight. This outgassing would create a gentle push, explaining the change in speed without producing a visible tail. ʻOumuamua entered the solar system from interstellar space and followed a hyperbolic trajectory, meaning it was never gravitationally bound to the sun. After passing near the inner planets, it continued outward and is now far beyond detection range. Tabby's star, also known as KIC 8462852 or Boyajian's star, is famous for its strange and unpredictable brightness changes. Unlike typical stars that dim slightly when planets pass in front of them, this star has shown irregular dips of up to 22%. Some of these dips lasted for weeks, which is far longer than expected from normal planetary transits. The phenomenon was first identified using data from the Kepler Space Telescope. Scientists initially proposed large clouds of dust as a possible explanation, but the pattern did not fully match known behaviors. The dips vary in depth and duration, making the cause difficult to pinpoint. Some observations suggest that fine dust particles may be blocking the light, while other studies explore more complex scenarios involving debris from broken objects. Because the star's behavior does not follow a simple repeating pattern, it remains one of the most unusual stellar mysteries. Hoag's object is a nearly perfect ring-shaped galaxy located far beyond the Milky Way. It consists of a bright circular ring of stars surrounding an isolated central core with a large empty gap between them. This structure is extremely rare and does not fit typical galaxy formation theories. Most ring galaxies form after collisions with other galaxies, but Hoag's object shows no clear evidence of such an event. The outer ring is composed of older stars, while the central core rotates independently, suggesting a complex formation history. Inside the ring, astronomers have even identified a smaller, distant ring galaxy visible through the gap. This creates a nested appearance that adds to its uniqueness. Only a very small fraction of galaxies have this type of structure. Because there is no obvious gravitational interaction or collision remnant, scientists continue to debate how such a perfectly symmetrical ring formed. Haumea is a dwarf planet located in the Kuiper Belt beyond Neptune. It is one of the fastest rotating large objects in the solar system, completing one rotation in about 4 hours. This rapid spin stretches the body into an elongated, rugby ball-like shape instead of a sphere. Haumea is believed to have formed after a massive collision that stripped away much of its outer material. Evidence for this impact includes a thin ring system surrounding the dwarf planet and 2 small moons orbiting nearby. The fast rotation also contributes to its unusual ellipsoid form. Unlike most dwarf planets, Haumea's surface appears relatively bright, likely due to the presence of crystalline ice. The combination of rapid spin, elongated shape, and ring structure makes it highly unusual. Its formation through a violent collision provides insight into how chaotic the outer solar system may have been during its early history. Hyperion is one of Saturn's most unusual moons, known for its irregular shape and sponge-like appearance. Its surface is covered with deep craters that give it a porous, almost fragile look. Unlike most moons, Hyperion does not rotate in a synchronized manner. Instead, it tumbles chaotically, meaning its orientation changes unpredictably over time. This chaotic rotation occurs because of its irregular shape and gravitational interactions with nearby moons. Observations from the Cassini spacecraft revealed that Hyperion's surface accumulates static electric charge. This charging happens as it interacts with charged particles in Saturn's magnetosphere. The irregular terrain and low gravity allow dust and small particles to stick to the surface. Because it lacks a stable rotation and has such an unusual structure, Hyperion looks very different from typical spherical moons. Punctum is a recently identified radio source detected using the ALMA observatory. It appears as an extremely bright point in millimeter wavelengths, stronger than many known sources associated with supernova remnants. The object is located in a nearby galaxy and does not match existing categories of known cosmic emitters. Its radio emission is unusually intense and compact, suggesting a powerful but highly localized energy source. Because it is visible mainly in millimeter wavelengths, it remained hidden from earlier optical surveys. Scientists are still studying whether it could be linked to an unusual supernova, a compact object, or a new class of astrophysical phenomenon. The lack of clear counterparts in other wavelengths makes it difficult to classify. This discovery highlights how new instruments continue to reveal unexpected objects. Punctum remains largely unexplained and may represent a previously unknown type of cosmic radio source. The Fermi Bubbles are enormous structures, extending above and below the center of the Milky Way galaxy. These bubbles stretch roughly 20,000 light-years in both directions and emit gamma rays and X-rays. They were discovered using data from the Fermi Gamma Ray Space Telescope. The bubbles appear as 2 symmetrical lobes rising from beyond the galactic core. Scientists believe they were created by a massive energy release in the past. One possible explanation is that the supermassive black hole at the center of the Milky Way consumed large amounts of matter, producing powerful outflows. Another idea involves intense star formation activity generating strong winds. The structures contain high-energy particles moving at near relativistic speeds. Despite their size, they are invisible in normal visible light and require high-energy observations to detect. Their exact origin is still debated, making them one of the largest unexplained features associated with our galaxy. Jumbos are free-floating planetary mass objects discovered in regions like the Orion Nebula. These objects are roughly the size of Jupiter, but do not orbit any star. Some observations have revealed that many of them exist in pairs, orbiting each other like binary systems. This is unusual because traditional models suggest that planets form within disks around stars. The presence of binary rogue planets challenges those models. One possibility is that they formed directly from collapsing gas clouds, similar to how stars form, but on a smaller scale. Another idea is that they were originally part of star systems and later ejected through gravitational interactions. Observations from advanced telescopes detected hundreds of these objects, suggesting they may be common. Their existence implies that planetary formation may occur in more ways than previously understood. These isolated planetary pairs drift freely through space without any parent star.